I get the pleasure of being after lunch, so my goal is to keep you all awake. So, welcome. Thank you to IIA for inviting me to speak today. I appreciate it. I've only been with Southwest for about 3 years now, and I engaged with Southwest initially as a customer. And I think when we look at Southwest, when you think of it as a brand, we think of it as the airline that Love built. We think of some of our quirky commercials that we run and our fun flight attendants that like to sing and tell jokes. And there's quite an interesting culture in our company that's based on warrior spirit, servant's heart, and fun-loving attitude. But behind that very warm, fuzzy exterior actually beats the heart of a fierce competitor. Our company has a mission to connect people with what's important in their lives, whether that is a business meeting or a graduation or a wedding. We take this very seriously, and we have to use analytics to make sure that we can actually deliver that. Our mission at Southwest, our vision, if you will, is to be the world's most loved, most flown, and most profitable airline, which we've achieved the profitability part. We've been profitable for 45 years, which a profitable U.S. airline, that's almost an oxymoron. It's quite uncommon. But Southwest was very successful before they started using analytics, and we're just trying to figure out what can we do to further improve the bottom line and improve the customer experience using analytics. A lot of the speakers today talked about how to link your corporate strategy to analytics, and I think that's very important. Our CEO, Gary Kelly, says that every single thing that we do, including analytics, ties back to one of three things. It's hospitality, reliability, and efficiency. And we have very specific metrics for all those things that we'll talk about. But today, we have 700 aircraft serving 100 different cities in the US and the Caribbean and Mexico. And we're flying 4,000 flights a day. And that started with 3 aircraft serving 3 cities back in 1971. So we've grown quite a bit. And the logistical and operational complexity that goes along with that really does mandate analytics to achieve a competitive advantage. And it's really quite a competitive necessity in today's competitive environment. So I like to say that I was into analytics before it was cool. Brad Pitt kind of made it cool, if you will, when he came out with the movie Moneyball. But I started my career at American Airlines in a field called operations research, which is really kind of a precursor to analytics. And frankly, the airline business was facing deregulation at that time. So when you deregulate an industry like that, like telco and trucking and railroad have gone through, that's quite a cataclysmic event. We had to figure out very quickly how we were going to make money in a deregulated airline environment. And we'll talk about the characteristics of the business in a minute. I, frankly, was amazed that when another first-run movie came out about data mining called The Big Short, about the mortgage industry, I never in a million years thought that we'd be making movies about analytics and Wall Street, but we did. And quite frankly, I don't think anybody expected Theo Epstein to lead the Red Sox and the Cubs for the last 13 World Series with using analytics. So I think there's definitely something there, so to speak, and congrats to all the Cubs fans in the room. You can pick up any one of these publications on any given day and find an article about analytics. And the one that intrigued me the most recently was an article in Forbes that said that data analytics is no longer a nice option. It's the core of the enterprise. And that article was based on a publication by Dun & Bradstreet about analytics going mainstream. And the quote at the end of it that caught my eye was, "Data analytics is the new competitive differentiator." And I think a lot of speakers have talked about that. We figured that out in the airline industry a long time ago because it was frankly a matter of survival. And now we carry that tradition forward with analytics at Southwest. Some people have said that data is the new oil. Some people don't like that phrase because data is renewable and oil is not, but I like to use that phrase, and we have a lot of data at Southwest. We run $19 billion worth of revenue through 2 websites. We use clickstream data to figure out who's shopping for what and buying what. We just implemented a new reservation system, which you may have heard of from a company called Amadeus. It uses real-time and dynamic pricing principles to make sure that we're maximizing the value of every seat. Our supply chain really boils down to fuel, planes, pilots, passengers, and peanuts. And we use analytics throughout all of those phases of our supply chain operation. So we are very much inundated with data. And I know that in the mobile space, which is growing, we have a new cool mobile app. There are more mobile apps, or more mobile devices on the planet now than there are people. So we're very much aware of that volume of data. I came up with a corollary to that data is the new oil strategy. I said that if data is the new oil, then analytics is really the refinery. It's the refinery that takes out all the impurity and it really cuts through and clarifies and crystallizes what are the best options, whether they're predictive or prescriptive. For business value, as Jeff said earlier, business value is up to you. We have a lot of different metrics. We use on-time performance, and we'll talk about some of the other ones later, but we use return on invested capital. That's our measure of profit. So everything that we do with respect to hospitality, reliability, and efficiency rolls back to a particular key performance indicator that we measure and we manage. So running an airline is a really tough business, and there are a lot of good quotes up there from some of the luminaries in the industry. But if you think about why the business is so hard, first of all, it was regulated, and there are reasons businesses are regulated. High CapEx cost of planes and hangars and facilities. You have basically a perishable commodity product that you need to put on the shelf in the form of a schedule about 9 months in advance, or even up to a year in advance before it's going to be sold. But most of your demand does not materialize until within 60 days of the flight actually being flown. We've got variable demand. It's highly seasonal. It's subject to consumer preferences and price, very price sensitive. We have a majority unionized labor force, which we have 6 different unions that we're dealing with for 80% of our labor. And frankly, there are a lot of factors beyond our control. I can't control the weather. I can't control the price of fuel. I can't control when the tower in Austin is going to flood, which it did, or the Chicago tower here at O'Hare caught on fire. There are a lot of uncertainty, and we have to try and use as much data and analytics as we can to try and predict and anticipate, but at a minimum react to that kind of uncertainty. But that's why the airline business has been such a challenge. So people have asked me, why do airlines use analytics? And I think we answered this question earlier. Frankly, it's a strategic competitive necessity at this point. As I said, AA was doing this back in the 80s, Delta, United, all the majors do it. I'm not sure about the ultra low cost carriers, but a lot of these products have become commoditized now. You can buy a revenue management system. Frankly, our operation has gotten so large and so complex with each aircraft flying 6 legs a day. The challenge is you really need computers and information and algorithms to basically manage the enterprise. We have been able to achieve some, what I would call operational and strategic competitive advantages using one of our case studies that I'll talk about today, our IROPS optimizer. IROPS is irregular operation. So the goal there is we had a schedule, we planned it out, but something happened. The weather happened, something else happened. We have to try and put that schedule back together, get people where they want to go with the crew and the aircraft and the flight all matched together. Frankly, at the bottom line, literally, is we do analytics because it is measurably transformational. IDC reported that the median ROI is 145% on a project when you do analytics versus 89% when you don't. Frankly, that's low for us. If we invest in an analytics project, we typically get in the high 3 figures of ROI and many times even into the 4. So if I'm putting 6 or 7 figures into a project, I fully expect to get 7, 8 figures out, and sometimes even 9 figures. So these are very strategic necessities for our company. So Tom Davenport talks about the analytical organization prerequisites. So at Southwest, we currently have about 60 terabytes worth of data in our enterprise data warehouse. That might sound like a lot. It's really not. It's not even big data if you consider big data is 100 terabytes. But we're actually going to start collecting even more of that data using data lake technology going forward. I've talked about our enterprise view. We literally start with the corporate strategy and we align every single analytics project with the metrics that we're trying to achieve. We have got quite a bit of leadership support within Southwest. Our president, Tom Nealon, is our former CIO. So he was the CIO, he went to JCPenney and he came back as president. Tom is a huge hawk when it comes to data and analytics, and he is really amping up our game. It's one of the reasons I came to Southwest knowing full well we were going to really start doubling down on data going forward. All of our executives, our COO, our CFO, they're all clearly bought in to what we're doing, and they're behind us 100%, and that's really super important for us to be successful. I'll talk about some other targets in a minute, but I did mention on-time performance, mishandled bag ratio, cost per available seat mile. We'll talk about some of those metrics, but we measure every single project that we do against those. We have about 200 data scientists or advanced analytics folks in the company, spread around the company. I'll talk about how we're organized, but about 5% of those folks have PhDs. Many of them have master's degrees in a variety of different topics. We recruit from a lot of different schools, including Texas schools and Georgia Tech and some other ones. But the real key is changing the culture of the company. Sometimes it's difficult to be the math guy in the love airline. People will say, well, gee, we were doing really well before you got here. What are you going to do different? And one of the things we're doing is we're changing the culture to be a fact-based test and learn culture. Let the data speak. And frankly, if you don't have an opinion, if you don't have data, you're somebody else with an opinion. So we're trying to reinforce that test and learn culture that was referred to earlier that companies like Amazon use every day. So originally, when I got here in 2014, we were very much decentralized. We had a lot of citizen data scientists spread out through various departments. I've got some of my colleagues here today from finance and corporate strategy and from our network operations control group. And they were all functioning very well in their respective areas, but we thought that we really needed an umbrella structure, something that could bring together best practices, standardized methods, standardized technology tools, giving self-service analytics enablement. So we actually created the Data Science Center, which I don't get too hung up on data science versus analytics. I personally prefer analytics. There's quite a bit of overlap. But the data science organization was created as a joint venture between corporate strategy and technology, where I reside. We had executive level sponsorship up to our president. And now what we're seeing is a lot more collaboration, a lot more sharing of information. I know we're not going to get to one version of the truth. We're going to have a fact layer that is our one version of the truth, and then semantic layers that are various versions of the truth. Because if you say revenue to a finance person and an accounting person, you might get two different stories. But the Data Science Center has been in place for about a little over a year now, and it's quite successful, and we're having regular communications with both a core team as well as the entire team. And as I said, there are about 200 folks across the company in that organization. This is a list of all of the different departments that are using some way, shape, form of analytics, whether it's descriptive or diagnostic, all the way up to predictive and prescriptive. That's my department there at the top, Enterprise Data Analytics. Corporate strategy and our team together jointly support doing projects around the company. So you could say that we're a centralized group, but our network planning organization, they actually use quite a bit of prescriptive optimization. And if you think about building a flight schedule, you're trying to build a network that will enable you to maximize the revenue with the aircraft you have and the capacity that you have, building in maintenance opportunities. Crew scheduling is a very complex problem. Anybody that's tried to build any sort of crew schedule is very challenging. Now imagine with 10,000 pilots and flight attendants. It's mathematically a very complex problem. It has a huge cost implication. After fuel, it is our number one cost driver. Revenue management, we have to forecast demand, and then we have to allocate our capacity on our O&D or origin destination legs so that we maximize revenue on every flight. That's a little bit more challenging for us because we don't fly to hubs like to San Diego, Dallas, and back. We may start in Dallas and go to Shreveport, Tampa, Charlotte, and then Midway. So we fly these point-to-point legs. It's a little bit more complicated to try and forecast your demand and then price those segments out for Southwest. I won't go through all of those, but it gives you an idea of the spectrum of the different organizations within Southwest that are using analytics, a variety of forms. We have different engagement models. I mentioned self-service. A lot of these departments do their own thing. They literally have systems that maybe my organization maybe built a data warehouse for marketing, but they have their own analysts that are doing their own predictive and analytical models. Sometimes we engage third parties. There are certain third-party companies that have expertise in a particular area, like flight scheduling. Optum is one of those companies that we work with that we've partnered with to build a next-generation flight scheduling system. We work with consulting companies. So my partner, Doug Cochran, is working with Deloitte right now on a video analytics project. So that was something that we wanted to bring that expertise into the house and we're using a third party. We do have solutions that my team builds with our business. Those are usually mission-critical production systems. In technology, and I saw a Gartner paper the other day, their forecast for 2018, it said that companies that are getting the most traction with analytics have a very close linkage between analytics groups and technology. And Tom has talked about in his books that the most value from analytics comes when you can embed them into processes and they're literally running like artificial intelligence in the background. This type of progress that we've made, it really requires mutual engagement from the business customers who are business domain experts. We need their leaders to buy in. And then we need all functions within technology, from software developers to testers to even our infrastructure folks to allocate capacity. So these are some of the departments, actually a pretty good list there of almost all of them. This is my org. It's a little bit on an eye chart. I don't expect you to read this, but on the far right-hand side, I have one manager that's dedicated to descriptive analytics. So we use business objects and Crystal for our standardized reporting. We also use Tableau for our self-service dashboards and data visualization. On the far left-hand side is my advanced analytics group. That's really where we're doing the large majority of our predictive and prescriptive work. That's very heavy-duty optimization, mathematical programming for flight scheduling, crew scheduling, predictive analytics. We'll do a little case study in a little bit. And that group is about 20 people right now, 20 to 25, depending on projects. And all three folks in the middle there, they're building our data platforms, various versions of our data warehouse. For Mosaic is our new tech ops system, our maintenance and engineering system. Titan is our new operations system, and we just completed our Lone Star rollout, which was our new reservation system. So every single ticket that gets booked or changed goes into that data warehouse so customers and customer service representatives can access that on the back end. So I have that, what we call data at rest, or an analytical data foundation that is bookended by two analytics groups that not only build analytics solutions, but with self-service, we actually support and enable our citizen data scientists. I'm not going to go through these, but this just gives you a range of all the different methods that we're using. I heard a lot of talk earlier today about machine learning. That's one of the hot areas that we're definitely doing a lot of work with tools like gradient boosting and random forest. But we also do kind of classical things like math programming, linear, integer, nonlinear programming. We also do discrete event simulation to simulate complex systems. So in our schedule development area, we actually build a schedule that maximizes revenue using network flow technology, and then we use a simulation model that overlays weather distributions and aircraft out of service distributions to simulate how that schedule is going to behave. So we can estimate, if I take this schedule, how is it going to operate? What is its on-time performance? So very wide range of methods used across the spectrum and across the company. These are some of the targets. So Tom talks about targets all the time. We have to link our analytics work. So RASM, revenue per available seat mile, that's the amount of revenue that we collect for every seat mile that we fly. CASM is cost per available seat mile. That includes our fuel costs, our crew costs, our cost of our aircraft, and cost of facilities, both CapEx and OpEx. Everybody here cares about on-time performance, so do I. We're going to do a little case about that in a minute. Mishandled bag rate, everybody wants to get their bag. And then finally, net promoter score. So Southwest has been very successful right now. Our net promoter score is around 60%. We're quite happy with that. We're working on the mishandled bag ratio as well. But every single system, every single process, every time we embark on analytics, it ties back to one of these metrics, including metrics like ROIC and others. So this is the way we were all trained to do analytics, right? We frame the problem or decision, we model it, and then hopefully we can communicate and act on the results if they're going to be a tangible economic impact. I'm a big believer in embedding models in systems. I also would tell you that doing a model, if it's a 1 on a scale of 1 to 10, embedding it in a real-time system and making a real-time control system is 10 times as difficult. The need for data, the need for quality, the need for keeping models tuned, the need for keeping users trained. I mean, it's an order of magnitude, in my experience, order of magnitude more complex enterprise, but a must-have, quite frankly, to get the most value out of these systems. So I'm going to do a little bit of an exercise here, a little audience participation since it's after lunch. How many people care about whether their flight lands on time or not? Everybody does, right? What do you think some of the most important factors are in determining whether a flight, if I said to you, what's our on-time performance of our network going to be tomorrow? Gate availability, good. Weather. Crew, excellent. Sure, excellent. Did I hear one over here? Equipment, having the right equipment for the right flight, right? So this is a graph, both actual and predicted, of our on-time performance from October 16th to May 1st, 17th. So the blue line is the actual, and you see that there's some really nasty dips in on-time performance. Those are 4 of the largest winter storms that we had over that period: Decima, Helena, Stella, and Arlene. The yellow is actually the predicted. And I would say if I take out some of those outliers, I would say that that model's doing pretty well. In effect, it's got about a 6% error rate. So we've had multiple models inside the company to predict on-time performance, whether I have a flight schedule or not. We wanted to take a different approach, and we said, if you can tell me the weather, the day of the week, because Tuesday is not Saturday in the airline business, if you can tell me the month of the year, so we have quite a bit of seasonality, and you tell me the load factor, which is the number of people on the plane, and then you tell me what air traffic control is going to do. If I have all of that data, which we do, we collected it all, and over a period of about 3 months, one of our top data scientists built this model. She used machine learning. She used gradient boosting, random forest, I think it was nonlinear regression, lasso ridge regression. She tested all those models, and the best one came out with about a 6% error. So a lot of the things that you mentioned, aircraft crew, it turns out that those are significant things, and we may very well add those in. We're doing a pretty good job right now because a lot of that comes out in the wash, quite honestly. But the really key factors, and we fit, somebody said they had 400 factors in their model earlier, Doug did. We probably looked at all those variables, but these are the ones that we were able to get to a good model in a reasonable period of time. So this is predicting on-time performance at a network level. Now we're trying to get down to the station, and ultimately we'd like to go to the flight. So it's a journey. It's going to keep going, and we're just going to keep renewing this process, renewing the data, and trying to make it even more effective. But I want to give an example of exactly the kind of stuff that we do. All of these factors up here, estimated time of arrival, passenger demand, maintenance checks, weather, they all drive considerable complexity into operating an airline. And frankly, it's a really tough job. It's a really tough operation to run. It's the closest thing to warfare and military, personally, that I've seen in my years of working. But people say, why bother? Well, it's all about the Benjamins at the end of the day. Because Herb Kelleher, our founder, said, if you take care of your people, they'll take care of your customers, and the financials will take care of themselves. That was when we had 3 aircraft and 3 people, up to 200 to 300. Now that we have 700 aircraft, we had to add some technology, add some data, add some math into the equation to really be able to deliver on that promise and deliver on the hospitality, efficiency, and reliability equation. We use a lot of different technologies, but we've really narrowed them down to the company. We program in C++, which is not up there, which might seem a bit dated, but we found that has faster performance than Java for a lot of reasons. It's closer to the metal. We do use business objects for our reporting. I mentioned that. We've adopted Alteryx. I know they're here today for our data blending. It integrates with R very nicely. Tableau is our data visualization tool. We are using R. Some people like to use Python. And we're a customer of FICO. Their Express and their modeler suite is the heavy-duty math programming optimizer that we use to solve flight scheduling, crew scheduling, and our day of ops performance system. Teradata is our data warehouse. We have a very close partnership with them. We are looking at moving into a data lake type of an approach and strategy. We are looking very closely right now and have several projects going on with Amazon to give us the kind of scalability and compute on demand that we need. A lot of our internal customers want to have all the data that they need. They want to be able to shunt it off into a workspace like a sandbox, but they want that same production data flowing into the EDW so they can have their production reports and their production systems run off of it. So that's a little bit of a jaunt in a new direction for us. We do use Hadoop. We've done some prototypes with Hadoop with our clickstream data, very high volume data. We are releasing a new aircraft. Some of you may have heard about in the news, the 737 MAX. It's a completely digitally enabled aircraft. So the engines, the APU, a lot of the airframe components are all digitally enabled with sensors. I know the next topic's IoT. I'm going to be very interested to hear all about that. We're now trying to figure out what are we going to do with all that data to do predictive maintenance and get the right part at the right place at the right time to make sure that that aircraft leaves on time and people can do what they need to do. So those are some of the platforms that we use. Somebody said there was a clock up here, but I don't seem to see it.
You're doing fine. I think you covered it up.
I covered it up. Okay, great. The clock was closed. Somebody closed the clock. Thank you very much. I appreciate that. All right, very good. So let's talk a little bit, since we're doing well on time, we'll talk a little bit about 2 case studies. So many of you may know at Southwest that we've been hedging a portion of our fuel purchases for a very long time. Our CEO, Gary Kelly, used to be our CFO, and he came up with that idea in 1986, and over the course of hedging our fuel, we've saved about $3 billion over that period. That's really great when fuel prices go up and you don't expect it to. Actually, hedging is actually quite a sophisticated analytical technique. If you use Black-Scholes as a multivariate normal distribution, it's pretty heady stuff. We use MATLAB for that. We don't do that ourselves. And we have a trading group that does our fuel hedging. About a year or so ago, our CFO realized that our unhedged fuel costs were starting to creep up. We no longer had that same cost advantage. We wanted to look into how can we do a better job of managing our fuel purchases both on an annual basis when we have to sign up with our vendors and say we're going to buy this much fuel at this station for the year, all the way down to our tactical fuel purchases on a monthly basis. So basically the approach that we took, we got as much demand data. We got about 3 years worth of demand data, fuel for all 100 of our stations on a monthly basis. We aggregated all that together, and we built an optimization model that we were able to tell our vendors, a simple, relatively simple linear program. You can write it on the back of an envelope. And it basically said we were spending too much money on fuel every year. We could actually meet our demands and find out that we could have gone and done with less fuel. And there's 2 kinds of bias in that type of a problem. There's a financial bias that says keep as little as fuel as possible because it's expensive. There's an operational bias that says I don't want to run out. I want to have more than enough fuel. So we tried to level that bias back out, and we're able to actually use optimization, use analytics to better forecast demand, using a lot of those same demand forecasting tools I mentioned earlier, combined with an optimizer. Some of you may have studied in like ops management or ops research. The EOQ, Enterprise Order Quantity Model, it's a classic technique. It's been around for 50 years. We started using that model. We implemented that model. We took a lot of data out of our Ariba system, our enterprise data warehouse, and a lot of what I call the 100-tab spreadsheet. We brought all that data together. We cleaned that data up. We were able to validate the data. And now we're finding that we're doing a much better job predicting exactly how much fuel we're going to need on a month-to-month basis. So we submitted that case study to Alteryx, and it actually won their best Best Business ROI Innovation Award last year in 2016. And the guy on the right there is Dr. Omid Medadi on my team, PhD in supply chain management and ops research. Super smart guy, and nicely enough, one of the most humble people that you ever want to meet. So he did a really great job on that project. And that was our fuel supply chain inventory management project. One other one, and I can't say a whole lot about this because this is literally one of our strategic competitive advantages. But the problem, when you take a flight schedule and you actually go to fly it, it turns out that that flight schedule gets changed up to 30% every day. So of 4,000 flights, 1,200 of them have some change. Departure time, arrival time, crew, delay, swap, cancellation, something changes. Sometimes things change in a big way. So when we know that there's a snowstorm heading for Denver, this new system that we built, we call it the Baker. It's named after the gentleman that conceived of this idea, Mike Baker. He came up with the idea and said, if I have to solve a problem like a snowstorm in Denver and cancel all my flights into Denver over a multi-day period, that's a really hard problem. That's typically going to take one of our dispatchers 6 to 12 hours to solve that problem manually. This new system basically looks at all of the possible combinations of swaps and delays and cancellations and says, how can I put the airline back together to minimize the entropy that's been created by the weather? How do I put it back so I get everybody to their destination with as little entropy as possible? We're now solving that problem for Denver and other irregular operations in about 5 minutes. But as I said earlier, and somebody said earlier, it's not just the answer. We actually give the dispatchers 3 different answers, and they can pick which one they like best. But all of them are within some range of optimality. So this particular system, we submitted it for 2 different awards. Agafor's is an operations research organization, is an airline international group, won for best innovation. And then recently our optimization vendor, FICO, asked us to submit for this, and it won their Decision Management Innovation Award last year. I can tell you for a fact, when I started in the airline business 30 years ago, we were working on this very problem. We didn't have the data. God knows we didn't have the compute time. And quite frankly, I wasn't smart enough to solve it. And we have a couple of guys on our team that are PhDs in math and ops research. One in particular, Dr. Mark Song, who's world-renowned. He built our crew irregular operations solver. He also has been the one mind's eye, if you will. Those people are unicorns. I mean, you're lucky if you can find one of those people in your company that has that. He's literally a top 1%er. So we're very, very fortunate to have that caliber of people like Mark and Omid on our team. And they have, in this particular case, they've cracked a problem that has plagued the airline industry for decades. And it's really a super exciting result. We're getting great results out of it. It has improved our on-time performance. And most importantly for you, the passenger, wouldn't you rather get a phone call the night before to say your flight's been canceled and you've been rebooked instead of showing up at the airport at 4 in the morning for your 6 a.m. flight only to find out you're going to sit there all day? That's the customer experience that we're talking about. That's the hospitality, and frankly, it's the cost effectiveness. If we can put the right aircraft with the right crew in the right place at the right time, we get that kind of a result. And it's frankly quite spectacular. And we're very pleased about that. And our COO came up to me at our holiday Christmas party, Mike Vandeven, and he hugged me. And this is a big burly guy. He's kind of a tough guy, and he wouldn't be the first guy you would think to come up and give you a big bear hug. And he said, that Baker thing, he said, I don't have any idea how that thing works, but it's the greatest thing since sliced bread. Please go do more of that and do one of those. So it's pretty exciting when senior executives get that excited about something you're doing. Just a couple of closing thoughts, and then I'll open it up for questions. So I'm a big fan of what Tom has written in his books and the methodologies that he's put forth. And frankly, I saw them as just an echo of things that I've been trying to do for 30 years. But he and Gene smart enough to put them down in a book, for all of us to be able to read in a nicely organized fashion. But I believe that they really do work. I've used them my whole career. I've used them, I've teach them in my course at SMU. I think the big part of our success. I told Tom I've sold about 80 of his books because all my students, I make them all buy them. So I'm not looking for a check though. So I think that the closer you can align the use of analytics with your business strategy, the better. You got to be curious. You have to dig in deep and really become partners with your business. Whenever we work on these projects, we literally co-locate our data scientists. They sit with the business people. Am I out of time? Oh, I thought that was the out of time signal. We focus where we get the big bang for the buck and the big value multipliers, crew cost, fuel cost, on-time performance. Our goal is to make ourselves indispensable to the business as a service provider. We do focus on outcomes against the KPIs, and frankly, I tell all my analysts, you never want to be the person with a technique or a tool or a solution in search of a problem. Nobody wants to hear that. Somebody said earlier, don't talk about machine learning to somebody that hasn't already used those words to you, because they probably don't want to hear about it. Somebody else earlier today said, start small, move quickly, fail fast, learn. We time box all of our modeling projects. We try and do modeling projects in 3 to 6 months. large-scale systems development. Sometimes those can take years, like the Baker. We started working on that. It was a hard problem. Back in 2009, we've been working on it for 10 years, and we're constantly improving it. But for modeling projects, we try and time box those, and then we increase scope and scale. I think the most important lesson that I've learned in 30 years of doing this is let your customers internally take all of the credit. Because if you can help them save the airline 8 figures, I get the pleasure to come here and talk to you and tell my story, but I let them go tell the senior VP of finance. I let them take credit for all that. And they go, yeah, we got these new cool tools that we're working with technology, and we've made some really big improvements, because there is a bit of cheese moving going on here. And frankly, analytics can be creative destruction. It can be very big on the change front, and we have to be sensitive to that and manage that. So frankly, at the end of the day, I mean, I do this because it's really, truly, measurably transformational. We've seen huge results, huge financial impacts, economic impacts, customer service impacts, and frankly, several quality of life impacts. If you can get a crew member home at the end of their trip and not delay them and keep them in a hotel for another day or two, that's a big impact on their lives. If you can take an analyst that used to have to crank through spreadsheets for 3 days, and now he hits a button and gets a better forecast for fuel demand, and that person could go home and they can go back to doing their day job, that's a huge impact. And it's a softer impact than maybe the hard dollars, but it's a quality of life impact for our people. So that's it for me. I'd love to take any questions that you have, but thank you very much.
I have a question about the change that you made in the organizational design between 2014 and 2016. Actually, 2 questions. First, what was the impetus for that change? What was the driver from a corporate perspective? And then the second question was, as you were deciding to go from that decentralized model to, I guess, a centralized model, what kinds of conversations did you have to have with your business partners to help them understand that that was a good move, to take their resources from the decentralized and bring them in?
Great question. So the first question, our president, Tom Nealon, was the impetus really for creating the Data Science Center, because he saw all these people doing great things in their various pockets of their organization, but he wanted to scale that up. He wanted to make it an enterprise capability. He wanted to make it a truly strategic competitive advantage across the whole company. And he really, frankly, was the guy that kind of brought that idea together, sold it to the executives. And I'm a co-sponsor of that, and a lady named Angela Morano in our corporate strategy group. She and I are the director level co-sponsors. We work very closely together. In terms of the second question, it's not really centralized in the sense that all the data scientists are in one physical location or all in one department. They're still spread out in their various departments. But now we have this umbrella. It's a community. We call it a community of practice. It's not a center of excellence. A center of excellence, I like that term. To some people at Southwest, that implied that it was all happening in one place and only the people in the excellence group could be truly excellent. So it's a community. It's a community. It's 200 data scientists. We meet as a group. What is it, Doug? Is it like quarterly, monthly? We have like community meetings, quarterly, monthly, where people come in, they'll present, they'll talk about a new model that they built, they'll talk about a project, they'll talk about the value, they talk about where they got the data, because we have all the same issues that everybody has talked about today. And that sharing that happens about, I've gotten success with these tools and not these, or this data set and not that data set, that collaborative model is really critical. And frankly, we started with maybe 50 people that were involved in the community, and now we have 200. So I think word is spreading, and people are more excited about working with their peers. And in the airline business, and maybe it's the same in other businesses, there's quite a bit of domain knowledge that you need. If you're working in revenue management, in fuel, in flight scheduling, you really need to know that business to build models around it. It's very, very sophisticated business logic that you have to be able to adapt to. So I would say we've gotten only very positive feedback. There was some skepticism at first. What's in it for me? What am I going to get out of this? Why am I going to these meetings? But now I go to them quite regularly, and I find them quite interesting and informative to see what people are doing. And then in addition to the whole community, we have a steering group of about 12 folks. And we meet to talk about putting new tools into place like collaborative tools, data management, data governance tools, so everybody can share in that. But I would say it was relatively positive, and it's only continued upward.
Hi. You mentioned in your recovery solution
Yes.
that you allow the dispatcher to choose from 3 options.
Yes.
So curious, 1, what's the rationale? 2, do you rank order them? And then 3, what is it the dispatcher knows that somehow your model doesn't reveal?
That's a great question. And you know, initially when we started building that model, we had a beat the baker contest every day when we were testing it, and the dispatchers were winning 50% of the time. And they knew things that we didn't know, but as soon as we figured out, well, you forgot about this, we got that data and we factored that variable into the optimizer. And then that number went from 50 to 40 to 10 to 5, now it's 0. So no dispatcher can ever look at the solutions and go, I could have done better than that, and here's what I did. If they did, it would have taken them 8 hours anyway, right? So that collaboration between those dispatchers and the people that built the model, they literally sit next to one another in the office, and they literally sat in a room, which we dubbed the bakery. They literally sat in a lab environment for 3 or 4 years when we were going through the very rigorous testing. And I would say that those solutions, normally, they're indistinguishable from one another. I mean, there may be small differences. I swapped these 2 aircraft versus these 2. I canceled this flight versus the other. Oftentimes, it really, at this point, given how much we've tuned the model, because we're on release 3, I think, going on release 4, we've really smushed out a lot of the variability and the stuff that we don't know. And now we're adding in other large chunks of functionality. Yes, sir.
So I love this irregular operations thing. It's very cool. I've worked similar problems, but have you taken the irregular operations and now on the journey actually started changing your daily one so that you can make that a little bit more robust so your irregular ones are actually easier to change versus there may be a small cost in the one, but you get easier irregular.
There's a feedback loop that's a lot stronger now between our NOC, our Network Operations Control Center, and our flight scheduling department is getting stronger. They're giving them more feedback about what worked. Things that we deal with a lot are like block times, which is the length of a flight. That changes for a lot of different reasons. De-icing, for example. Mm-hmm. Same flight midway to Dallas, but in the winter you're de-icing. So block times change, crew connect times change. Depending on the season of the year, the terminal's more crowded in Orlando in the summer because everybody's there on vacation. So this has just been the beginning of an iterative feedback loop, and we are getting better schedules now as a result of not only the Baker, we have another tool that I mentioned earlier called Sky Sim. It's actually a simulator. So we take a flight schedule and we literally fly it in the computer with delay distributions and weather distributions and things, and that's added quite a bit of value to that feedback loop to tune schedules. Yes, sir.
Thank you.
So now you've optimized your fuel and your other costs, and now you've started to optimize your irregular operations. When are you going to put the 2 of them together?
So we actually have an optimizer. It's called fuel tankering. It's part of that equation where we'll buy fuel where it's cheaper. We'll buy it in Albuquerque versus buying it in California, fly up the coast. And we'll eat the cost that will burn a little bit more fuel because now the plane's heavier, but we use a linear programming model to actually do that on the day. That system's been there for a while. And I think that those 2 things actually are linked together because when we do our forecast for our fuel, we look at how many flights did we fly, both scheduled, unscheduled, charters, diversions where we have to fly to a different airport. So we collect all that historical data about what really happened, and that's really what drives our forecast for the future based on those key variables. So they are linked together that way. No, not directly. I mean, somebody asked me once, couldn't you just put all of your problems into one big optimizer for flight? It won't work. You have to kind of break the problem up, but what we are trying to get better at is feedback loops, right? flight, crew, fuel, ground ops, maintenance all the way back. And those used to be silos. I mean, because when the airline was small and you had 45 planes, it didn't really matter. You could get away with a lot of warrior spirit and get through the day. You can't do that anymore. So Tom Nealon, as part of this effort, was like, I really want to see those silos broken down and start collaborating more. I think I'm done. Very good. Thank you very much. Appreciate it.